What's up, homies? It's our time to do the mid-chapter review, so buckle up and let's get started. Go ahead and pause this video and see if you can answer this slide. All right, let's check your answers here. So list a set of data that's right skewed. So that's something that looks like this. Okay, why do I know that? Well, I memorize it because this is a tail, and I'm going to take that tail and I'm going to pull it this way. That's right skewed. But a set of data would mean basically we have a bunch of stuff on the left. So maybe 1, 2, 3, 3, 3, maybe 4. And then we have kind of an outlier on the right. So maybe something like 27. Okay, so there would be the 27 would be here with the low frequency, and then the majority of the data is on the left. All right, next question. Draw a symmetric distribution. That's going to look just like that. All right, next question. Find the min, Q1, median, and Q3. Well, the median is 5. All right. And then we need to find the median of the left data. That's going to leave me with 4 for my Q1. And then same thing here. Helps when you make those noises, is 7. All right, now what's our min and our max? That's pretty simple. Our min is our lowest number of 2, and our max is our highest number of 8. Just a nice review. Let's go ahead and do this one. So we have the heights of 250 21-year-olds or 20-year-olds, and it's normally distributed with a mean of 1.68. I'm going to put that mean right there. And a standard deviation of 0.06, meaning I need to add in this direction, 0.06, and I need to subtract in this direction. So let's go ahead and do that. So I'm going to get a 1.74 here, and a 1.8, and a 1.86. Now I'm going to go ahead and subtract 1.62, and then a 1.56, and one more, let's say 1.5 here because I'm subtracting 0.06. Now find the probability that a woman has a height between 1.56 and 1.74. Well, where is that? That's happening from right here to right here. That is, here's my X bar. That's from 2 standard deviations to 1 standard deviation. So looking here, that is from here to here. I'm going to go ahead and add up those percentages. So that gives me 13.6 plus 34.1 plus another 34.1 is an 81.8, and that's a percentage out of 100. Now for probability, we don't want to have decimals, so I'm going to move the decimal over to the right one or times it by 10, and that's going to give me 818 over 1,000. What does that reduce to? Well, I can divide both by 2, and I get 409 over 500. So the probability is 409 out of 500. All right, next question here is about how many women have a height from 1.62 to 1.8. And just as a reminder, 250 women were surveyed. All right, where are we at here? Well, 1.62 right here to 1.8 right here. So we're talking about, if this is my X bar, being 1 standard deviation to the left all the way to 2 standard deviations to the right. So looks like that is 1 standard deviation to the left, and we're going 2 standard deviations to the right. That's also going to give me an 81.8% if I add up those values, this one, and this one. But I'm trying to figure out how many of the women are in this range. So I'm going to take 0.818. I'm going to multiply it by the 250 women surveyed. And doing that math, I get 204.5 people. Well, I can roughly say that that's about 204 people. You could have rounded it to 205 as well. I'd give you credit for that. Alrighty. All right, here we go. Another review here. So the average times in minutes it takes students to get to school in the morning are listed below. Round to the nearest 100th if necessary. Find the mean, standard deviation, and z-score for your own personal trip to school. Well, to do this, we can find the average pretty easily, add up all the values, and divide by the total number of items. Standard deviation is a little bit trickier. So for both of these two, I recommend you go back to the video where I show you how to do this on the calculator. All right, and I get an x bar of 17.3, and I get a standard deviation of 7.76. Go ahead and you should try that on your calculator. Make sure you can do it. Well, how would you find your z-score? You would use this formula right here. Okay, and to do that, you would have z equals whatever time it takes you to get to school. Subtract that. We got to do minus 17.3, and then you're going to divide by 7.76. And if you take less time than this, then you should have a negative z-score. If you have, it takes you longer than 17.3 minutes, then you should have a z-score that is greater than 0. Now, my z-score is negative 1.2. Find how long it takes for me to get to work. So what I do here is either use the formula I used before, but I'm not feeling like it. I think I'm just going to use this formula here and then solve. So I've got a z-score of negative 1.2, and that's going to be equal to x, which I don't know what that is, minus my average, which I know is 17.3, all over a standard deviation of 7.76. Okay, let's solve this for x. I'm going to multiply by 7.76 on both sides. Okay, times 7.76. And obviously this cancels, and I'm left with a negative 9.312 is equal to x minus 17.3. Add 17.3 to both sides. All right, this disappears, and I'm left with x equals 7.98, or roughly 8 minutes. And that is true. It takes me about 8 minutes to get to work. All right, that's it for our review. Looking forward to talking to you next about percentiles and z-score. But till then, make sure you do your assignments, and I hope you have a fantastic day. Please do not forget to pet your cats if you do have cats. Thanks so much. All right, bye-bye now.